This is a really challenging problem. This final problem is so difficult. If you're able to figure this one out, you are so ready for this exam. It's got everything. This part A is a logic nightmare, asking you to solve a really challenging logic problem. True confession, it took me longer than the 45 minutes to solve, especially Aardvark. So it is a big one. The first thing you have to do is understand the problem. The problem is asking you to take a word like tan, T-A-N, and go from left to right. And every time you say see an A, followed by a letter that's not an A, it's asking you to do a classic computer science swap. So T-A-N for tan becomes T-N-A. Do you see that swap in there? There can be a lot of swaps. However, what's interesting to note is if the last letter is an A, it doesn't swap it with a space, it just leaves it alone. Now this double A deals with that second rule where you have AA. How does it handle that? Well, what it does is it just swaps the second A out. So it's going to go A-R-A-D-V-R-A-K with that swap. And then it's only going to go through it once, which is kind of like a hint that, oh, this is a classic for loop. I'm going to go through the word once. Let's take a look at the default code and what I've given you to help you solve the problem. I've entered all those sample words with the expected results and written a method that just returns the exact same thing. So when you run it originally, you get the exact same thing back. Now, notice that I'm just returning word. I'm going to encourage you all to start every method by making sure you double check what is the return type. Well, the return type for this method is a string. So I'm going to return a string result. And just by doing this, you automatically get one free point because they almost always give a free point to just having the method return the proper data type. So let's run this method and see if I get back nothing. I did it. Perfect. I get my free point. Now the next challenge is to build up that result. This is a string building activity, and classic with all string building is that good old for loop. So I'm going to go through the word and get its length, and I'm going to make sure I go through that word and go through that word, each character at a time, depending on the size of the word. So next challenge, can I rebuild that? So I'm going to rebuild that by saying result equals result plus the word at substring I plus 1. Now when I do that, I should rebuild the exact same word in result character by character. And I was able to get back where we started. But now I want to use that character, one character at a time, to determine if it's an A. If it's an A, I want to then trigger the swap. If it's not an A, I just want to put in the letter that would normally go there, which is a classic if-else. So I'm going to say if the letter at word substring I to I plus 1 equals, and you notice I'm not using the equals equals, I'm using the object equals a literal A. If that's what happens, then I want to enter this and I want to do a swap. And if it's not an A, I want to instead do that result equaling result, sorry for my typing, plus word substring I to I plus 1. Let's just test that and see what happens. It should shrink down my words a little bit. Yeah, it cut out all the A's, which is exactly what I expected it to do. So now I have to figure out that swap. So here's how I'm going to build the swap. I'm going to say the result is going to equal the result. I'm going to build that string one character at a time. I'm going to take the word at substring. Instead of I, at my current location, I'm going to go to my current location plus 1, and that is going to return to me that second character. And then I'm also going to concatenate that with the A. I know it's an A only because it has to be an A. So that should do the swap of the character. But some of you are already probably cringing because you're like, hey, this is going to be greater than the size of the string. I bet that's going to throw out an error. And it does. Ooh, and it does this weird thing too, where that one I didn't expect. Oh, I know why. I also have to tell it to skip another character because now I've gone over 2. So I'm increasing the index by 2 when I do this. Let's run it again and see. This is the error I expected. Okay, so it just does it once, but look at that error. That error says I went out of bounds. When you run that, you're going to have all kinds of problems because you're going to exceed the bounds or the limit of the string. So what you have to do is you have to use an AND statement. And I'm going to say, I'm going to use that I plus 2 because I know the I plus 2 is giving me the problem. And if my I plus 2 is greater than the word length, then I know I don't want to run this condition right here. I want to just print out that A. I know it's going to be an A because of this part. So let's run it and see if that solves the problem. Boom. Notice the last letter of A is preserved. Now, this solution seems perfect except for Aardvark. For Aardvark, it does a crazy thing. It doesn't work for Aardvark. So how do you solve the Aardvark crisis? Well, what you have to do for that one is really tricky. You have to say, if that Aardvark situation exists, that is another condition that we're going to do a special thing for, and that's going to be the first thing I'm going to check for. The first thing I'm going to check for is I'm going to see if that word at substring to I plus 2, which is now giving me 2 characters, equals the new situation of AA, then I'm going to have that double swap, or that strange swap. And then else, if I'm going to do these other ones. So this is a really tricky piece of logic. It's a really tricky situation. But as you can probably already predict, we're into that I plus 2 situation again. So to avoid that, I'm going, because of shortcut expressions, I can prevent it from even getting here if I check it right away. And I say, hey, if I plus 2, again, is less than word length, and substring blah, blah, blah. So this is going to prevent it from reading that if it even exists. Now, just for fun, let's make sure this doesn't cause an error. No error, but our Aardvark is really messed up. It didn't swap it at all correct. Let's write the swap for that. So for the Aardvark swap, what we're going to do is we're going to say result equals result plus that A. Then we're going to use that word at substring I plus 2, I plus 3, plus A. Now, the reason I say is I'm going to I plus 3, and that might cause a problem. So I can't have an I plus 3 go into that. So I'm going to chop it off at the conditional and make sure I got that I plus 3 in there. And then I also have the problem of that I plus plus, but it's not just one I plus plus, it's 2 I plus pluses because I'm actually going 3 characters ahead with that. So I'm going to make sure I go I++, or I equals I plus 2, or I plus equals 2. All those would work. Let's see if that solves the problem. Whew. I have my Aardvark complete. That was a super rigorous and challenging problem. And if you're struggling with that, don't feel bad. That was a hard one, even for me. So good luck with this part A. If you can solve this, you are in really good shape. Great work, everyone.